Okay, so we are going to be putting solving logarithms together with our properties of logarithms. So basically everything we've done with logarithms, we're putting together today. So I'm going to solve 4 times log base 2 of x minus log base 2 of 5 equals log base 2 of 125. Now, I have a base 2 for all 3 of these logarithms, which is good. What I can do here is I have a 4 out to the front, and where that 4 came from was the power property. So really I can rewrite that 4 back to the x and say that it's log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. Now I'm subtracting 2 logarithms, so I can make it 1 by division. So I can say that it's log base 2 of x to the 4th over 5 equals log base 2 of 125. And we learned before that when we have 2 logarithms set equal to each other and their bases are the same, we can actually drop the logs. So what I'm dealing with now, let me use a different color, is x to the 4th over 5 equals 125. So to solve for x, I'm going to multiply both sides by 5. So I get x to the 4th equals 125 times 5 is 625. And then the 4th, so x to the 4th equals 625. So to undo that, I'm going to take the 4th root of both sides. So x equals, the 4th root of 625 is 5. So I get that x equals 5. So it's putting everything together now. My next example, I have log base 6 of x plus log base 6 of x minus 9 equals 2. So I don't have any powers happening because I don't have a number that's pulled out to the front of my logarithms. But what I can do is I have log base 6 of x and a log base 6 of x minus 9. So I can make that 1 by using multiplication since it's addition right there. So I can say that it's log base 6 of x squared minus 9x equals 2. Now, unlike the last problem, I don't have logs on each side of the equal sign. So the last example, I had a log on the left side and a log on the right side. I don't have that now. But what I can do is I can put this in exponential form since I don't have a log on each side of the equal sign. So my base is 6. I'm raising it to the 2nd power, and that equals x squared minus 9x. And now I'm going to be able to solve this like a normal quadratic. So this is x squared minus 9x equals 36. I need everything on the same side of the equal sign, so I'm going to subtract 36. So I'm dealing with a quadratic, x squared minus 9x minus 36. So I need factors of negative 36 that add up to negative 9. So that would be negative 12 and positive 3. So x minus 12, x plus 3. And now I'm going to set each one equal to 0 and solve. So x minus 12 equals 0, so x equals 12. And x plus 3 equals 0, so x equals negative 3. And before I circle my answers and call it good, I have to double check that when I plug in my solutions that I'm not taking the log of a negative number. So I'm going to plug in positive 12 here and here and see what happens. So log base 6 of positive 12, so that's good. Plus log base 6 of 12 minus 9, so that's 3. So log base 6 of 3, so that's good too. So those are both positive, so 12 is a good solution. Now negative 3, when I plug in negative 3 right here, log base 6 of negative 3, there is already an issue. I cannot take the log of a negative 3. So negative 3 cannot be one of my solutions. So I only have one solution here, and it's positive 12. yeah, this is my last example. So my last example, I have 2 times log base 3 of x minus 2 minus log base 3 of 6 equals log base 3 of 150. So I have the power property working here because I have this 2 out in front of the log. So I'm going to pull it back. So I have log base 3 of x minus 2 squared minus log base 3 of 6 equals log base 3 of 150. So now I have log base 3 on the left side, and they're being subtracted. So I can make this a division problem. So this is log base 3 of x minus 2 squared over 6 equals log base 3 of 150. And now I have a logarithm on both sides, and they have the same base. So I can drop the logs, and I can say x minus 2 squared over 6 equals 150. So now I just need to solve for x. So my first step in solving for x is I'm going to multiply both sides by 6. So let's see here. So I get x minus 2 squared equals 900. And now I can square root both sides. So I get x minus 2 equals plus or minus the square root of 900 is 30. And now I'm going to add 2. So I get that x equals positive 32, and I get that x equals negative 28 because I've got positive 30 plus 2 and then negative 30 plus 2. But I have to go one step further and make sure that I'm not taking the log of a negative number. So if I were to plug in positive 32 in for x, I would do 32 minus 2, which is 30, and I can take the log of a positive 30, so that's good. However, when I plug in negative 28 minus 2 is negative 30, and I can't take the log of a negative 30. So positive 32 is my one and only solution. And that is it for properties in solving logarithms.